Wait, previously done engineering with added information technology or electronics. That's the excitement and scope. From robotics to space technology, everything has been influenced by the power of electronics and communication. Now that we have seen the 4 core or evergreen branches, let's think a little bit about the other 80 odd branches that are available in the IITs for specialization, even at the bachelor stage. There are these branches, including my own, which I studied aerospace engineering. There is ceramic engineering, textile engineering, mining and metallurgy, and also the new branches, artificial intelligence, cybersecurity, cryptography, blockchain, and the other things. Now, at the undergraduate level, why are the core branches still called the core branches? Because it's easy for somebody to get a very good foundational base in engineering and then move on to the further specialization. If you take something like computer science right at your undergrad stage, there is no way you can move into a field like mechanical engineering. While the movement from mechanical engineering to a specialization like computer science is still possible. That's the big difference. The second thing that you need to consider before applying to a college for a very specialized or let's say new age branch is whether the college has enough facilities to provide you excellent education in that field. For example, if you consider aerospace engineering, make sure that the campus has wind tunnels, has mock-up aircrafts, has enough facilities to provide you with the basic grounding of aerospace engineering. There is no point in engineering in knowing just the theory. But beyond labs and demonstrations that are possible, the greatest asset for any engineering institution are the faculty members. Now, when we started Trinity College of Engineering, our chairman, Dr. Thomas Alexander, shared the vision that we should run an engineering college like a medical college. What does this mean? Both are professional degrees, which means you can work unsupervised at the end of 4 years or 5 years once you get the degree. But to run an engineering college like a medical college, we know that a very good medical college has practicing doctors who are training the next generation. They are doing diagnosis, they are doing surgery, they are meeting real patients, they are reading the latest research, they are immediately using the latest technology to help patients get better, to treat diseases. Similarly, when you pick an engineering college, make sure that the faculty members are people who are practicing engineers first, and then they are professors who are training the next generation, which means look for colleges which has active government and private projects going on, which have very good alignment with the industry, which have cutting edge research going on, or the faculty are consultants for the government and the private industries. So effectively, you will behave like an apprentice who learns real engineering that is going on. Another thing to be kept in mind is that in the real world, no engineer works alone. All the branches collaborate with each other in any engineering project. So it's only in colleges that there are skirmishes between this branch is better than that branch and this branch versus that branch and so on. In any good engineering project that you get into, a mechanical engineering graduate will work with a civil engineering graduate, or electrical engineer will work with a chemical engineer and so on. So please be aware that once in the real world, especially in our world where everything is being permeated by electronics and IoT and so on, all the branches will eventually work together. So look for a foundational degree that will give you basic engineering skills, which are to analyze a problem, to break it down into its subparts and start solving it and innovating it. This brings us to the next most important step. Our country, India, currently has people in higher education only less than 30%. And if you consider engineering alone, you will understand how privileged you are, even in India, to get an engineering education. Though people may say there are lakhs and lakhs of engineers coming out, considering the population of this country, that is still a minuscule, privileged population. So as an engineer, you have the responsibility not just to get a job, but try providing jobs to maximum people. Try improving the society. And for that, one of the routes is to think about starting up right from the college stage itself. That's what we will discuss next. Entrepreneurship and startup are two words that entered the popular vocabulary recently. Thanks to the excellent work that's being done by the Kerala Startup Mission, today Kerala has a flourishing startup ecosystem with around 2,000-3,000 startups. Most of these are obviously in the engineering side. Here I am sitting in the Trivandrum Techno Lodge, which is a business incubator that is housed inside Trinity. Now, when you are at an engineering college, which is backed by an engineering company, like Alladrak in the case of Trinity, not only do you have some kind of job security that then you are very close to an industry that can recruit you, but you will also gain further insights into what's going on real time in the industry. At Trinity, we have these incubator spaces and also the Kerala Startup Mission Guided Innovation and Entrepreneurship Cell, the IEDC, where our student and faculty startups operate. Now, as mentioned earlier, it's important to have faculty who are practicing engineers. We encourage our faculty to set up their own companies like Kinesis and Letmac, and recently started N Cleaners, which provides sanitized, professionally cleaned environments for workplaces after the COVID crisis. Now, when you are in a campus where there is entrepreneurship and startup, you will understand that the real world and engineering industry needs more skills than just answering question papers. It's important to write your exams well and get your degree with a very good CGPA, but equally important is to recognize that how real world projects get done involves a lot more other skill sets as well. Now, people might consider whether there is a big difference and a risk involved when trying to start up on your own. Consider this basic statistic. If you are looking for a government job and it's advertised for 10 vacancies, clearly around 1 lakh people or 100,000 people will apply. So your chances of success are 10 out of 100,000. From worldwide statistics, we know that 95% of the startups might fail. Still, the chance of success there is 5%, which is orders of magnitude higher than 10 out of 100,000. So which is more riskier? Trying to pursue an exam which you may or may not qualify and get a job, or starting on your own right at the college level, so that from day one you are gaining invaluable skills which will make you an excellent recruit for any engineering company, even if your startup idea fails. So this is the basic philosophy with which you can approach entrepreneurship. And like I mentioned before, we in higher education in India have a moral responsibility to be more job providers rather than job seekers. Hope you received a comprehensive and effective introduction to engineering. Now let's come back to the joke that was discussed in the beginning about engineers not getting enough salary compared to semi-skilled, unskilled laborers. Now the truth is, for an engineer right out of B.Tech, it's just the beginning of a career graph as compared to somebody else. They can go on to pursue higher degrees, take a management degree, run their own startup, and then sky is the limit. So it's just the beginning of a big, long career graph in which they can go higher and higher, farther and farther. So there is no fairness in the comparison of what somebody starts off as their salary as compared to somebody else. Second issue that we needed to address was the unemployability of B.Tech graduates. Here it's a deeper question of the education system. There is a difference between knowing something and actually being able to do something with it or using it on a regular basis. Now I'm sure everyone watching this video knows English, obviously, because it's an English video. But then how many are able to use English in a daily fashion? Be very fluent with it, use it for all the purposes. Now that's the difference in language. The same goes for calculus. You may know calculus, but do you use it? Are you able to use it in daily life to solve problems, to create plans, and so on? So that's the same difference. You may know a lot of engineering. If you pursued it in a campus where there is no hands-on application, no innovation, you are not exposed to the industry and the real uses of the theory that you are learning. But once you are in a campus where you actually do engineering, and engineering is doing, it's modeling and changing the world. And if you are familiar with it, then there is no question of unemployability. 100% you will be placed as soon as you leave the campus, or even while you're pursuing your meaningful final year their project. Now let's think about the third issue, about people pursuing other degrees. That's fine if you're passionate about it, if you have interest in the field, that's great. But do keep in mind that for higher education, most of the reputed universities in the world, a 4-year undergraduate degree is preferred. And in India also, at the end of a 3-year bachelor, unless you do another 3 years of masters, you're not considered great for employment in any of those particular fields. Consider medical education, which is expensive, and only the truly passionate and the really good go on to make their mark. But if you are really interested in serving the needy and the sick, then you have the option of pursuing healthcare electronics and going back into the same industry related to healthcare management. So I hope through this video you have received a fairly good introduction to the scope, potential and excitement of engineering. Please do join us into the world of engineering so that we can model, plan and change the world and leave our marks. Thank you for listening.